You ever see a mountain biker just flying through the woods and wonder what's really going on there? Well, it is so much more than just pedaling a bike on a dirt path. Today, we are going to unpack the science behind it, and you'll see it's this amazing mix of elite physiology, seriously advanced engineering, and even neuroscience. Okay, let's get into it. So first up, what really makes a mountain biker a different breed of athlete compared to, say, their cousins out on the road? Well, the answer isn't just in the athlete. It's in the raw, chaotic nature of the trail itself. The biggest difference, the real heart of it all, comes down to just one thing: how they produce power. It's not this smooth, steady, predictable effort. Oh no, it is something else entirely. Okay, now take a look at this, because this is fascinating. On the right, you've got the road cyclist. See how smooth and rhythmic that power output is? It's predictable. Now look at the left. The mountain biker's power profile? It's pure chaos. It's all about these massive, constant swings, from 0 watts while you're coasting to these huge, explosive bursts of over 500 watts just to get over a log or a rock. That 69% variation, that right there is the signature of riding off-road. So what kind of athlete does that kind of chaotic power demand create? Well, you can basically think of them as a human hybrid engine. They're perfectly tuned for both incredible long-haul endurance and just relentless, explosive power on demand. Let's start with that aerobic engine. A top-tier male cross-country rider has a VO2 max somewhere between 70 and 82. Now, what does that even mean? Simply put, it's a measure of how good their body is at using oxygen. And trust me, that is an absolutely elite, world-class number. It means their body is like a furnace, incredibly efficient at processing fuel to power them up these just brutal long climbs. And boy, did they use every bit of that capacity. During a typical 90-minute Olympic race, these athletes are holding their heart rate at over 90% of their absolute maximum. Just think about that. They are completely redlining for pretty much the entire event. It's just a phenomenal display of sustained, high-intensity effort. And here's the kicker. For more than 80% of the race, these athletes are operating above threshold. That means they're in the pain cave. They're pushing so hard that their muscles are creating waste products like lactic acid way faster than their body can clear them out. They are in a constant state of high metabolic stress. To perform like that requires not just fitness, but just incredible efficiency and resilience. And this chart really paints the picture of the different specialists within the sport. Just focus on the cross-country or XCO athletes for a second. You see these sky-high VO2 max numbers and incredibly low body fat percentages. It all points to the single most important thing for climbing, your power-to-weight ratio. Now compare that to the downhill athlete. They're built more like a sprinter, all about massive, explosive power for a very short, intense effort. But of course, the athlete is only half of the equation, right? So now we've got to look at this intricate dance between that human engine we've been talking about and the incredible engineering of the bike itself. On any given climb, a rider is constantly making this calculation in their head. Do I stay seated? Because that's way more efficient. It saves a ton of energy. Or do I stand up? Standing unleashes this huge burst of power to get over a technical route or some rocks. But man, it comes at a massive physical cost. And here's exactly why that cost is so high. I mean, just look at these numbers. This shows how much more your muscles have to work when you stand up. The rectus femoris, a key muscle in your quad, fires 38% more. And check out the vastus medialis, a staggering 58% increase in activation. You're simply recruiting so much more of your body, including your core and your upper body, which just burns way more fuel. Okay, let's talk tech for a second. Modern suspension is all about one thing: preserving momentum. And a key innovation here is the rearward axle path. So instead of the wheel just moving straight up when it hits a bump, it actually moves up and back. You can think of it like a momentum shield. It lets the bike just flow over those square edge rocks and roots instead of getting hung up and slowing you down. It's so clever. And here's another brilliant piece of engineering called anti-squat. So when you pedal really hard, your body weight shifts and it wants to compress or squat the rear suspension. And that wastes energy. So engineers design the bike's pivot points so that the tension from the chain literally pulls against that squatting force. And when you get it just right at 100% anti-squat, those two forces cancel each other out completely. What you get is a rock-solid pedaling platform where every ounce of your energy goes into moving you forward. Okay, so we've covered the body and we've covered the bike. But what if I told you that the benefits of this sport go way deeper than just performance? The impact it has on your brain and even your skeleton, is honestly profound. This quote from the research really just nails it. Mountain biking isn't just exercise. That combination of physical effort, being out in nature, and the intense focus you need creates a perfect storm that actively rebuilds and restores your brain. And here is the proof. Get ready for this number. Just 6 minutes of high-intensity cycling can boost a chemical in your brain called BDNF by 4 to 5 times. So what on earth is BDNF? Just think of it as fertilizer for your brain cells. It's absolutely crucial for learning, for memory, and for your long-term cognitive health. It's amazing. And that BDNF is just one part of this powerful neurochemical cocktail that your brain gets. Every single ride releases serotonin, which is a natural antidepressant, dopamine, which boosts your focus and sense of pleasure, and of course endorphins, which just melt away stress. It is a potent, all-natural boost for your mental wellness. Now, here's a benefit you probably never even considered. Road cycling is great for your joints because it's non-impact, but that can actually lead to lower bone density over time. Mountain biking, on the other hand, with all its constant, controlled impacts from the trail, provides what's called an osteogenic stimulus. That's a fancy way of saying those little bumps and hits are signals to your bones to get stronger. And the research is clear. Mountain bikers have significantly higher bone mineral density. That makes the sport a powerful tool against age-related bone loss. So with all this incredible science behind the athlete and the machine, how does someone actually make it to the top? Well, it's definitely not an accident. There's a highly structured pathway that takes you from your local trails all the way to a World Cup podium. And this is basically the model that national teams use. It shows that becoming a pro is a really long-term process. When you're young, you train to train. You're just focusing on skills and having fun. Then, as a teenager, you learn to compete, adding tactics and intensity into the mix. And finally, as an adult, you learn how to win, optimizing every single detail for peak performance. And the whole pro scene is only getting more and more legit. The international governing body, the UCI, has created this whole new structure where only the top 20 World Series teams get a guaranteed spot in the biggest races. It actually makes the path to the top more competitive. Yeah, but also clearer than it has ever been. Which, it leaves us with one last thought to chew on. We've seen how this human engine and this advanced engineering are working in this perfect, incredible synergy. So as both the athletes and the machines continue to evolve and get better, you have to ask, what is the absolute true limit of what's possible on two wheels off-road?